All right, ladies and gentlemen, let's take a look at solving some rational equations. Now, rational equations with solving means we have the equal here involved. We have numbers floating all over the place. What I want to do is I want to find y. So in the end, I need to get down to y equals. Well, here's the problem. I see fractions. Anytime I see fractions and there's an addition sign in the middle, I'm going to use common denominators to put those fractions together. So in this case, I'm going to put a 1 here. Now, what is the common denominator between 1 and y? Well, I'm going to need to put in a y here and a y here. That gives me y squared plus 6 all over y equals 5. Now, again, fractions. So if I have a fraction equals something, if it's a fraction equals a fraction, I can cross multiply. And I come up with y squared plus 6 equals 5y. At this point, hopefully you figured out what to do. Get everything to one side and break it up. In this case, we're going to get parenthesis, y minus 3 minus 2. In this case, set equal to 0, set equal to 0, y equals 3, y equals 2. It is basic algebra 1, algebra 2. Now, there's another way to think about it, and that's to go over here and look at a problem like this. In this case, I also have two fractions, and they have strange denominators. But if I look over here, this is a minus 4 plus 3. So if I could get common denominators on both sides, that might be super helpful. Well, this is okay. All I need to do is put in an a minus 4 over here. Now, over here it's not quite as easy because I have 4 minus a. A minus 4, 4 minus a are not the same thing. However, if we go up here and do a little looking, we have 1 minus x. If I factor out a negative 1, that makes this positive a negative, and it makes this negative a positive. And so negative 1 times x minus 1. So by pulling out a negative, I can reverse the subtraction. Well, in this case, if I pull out a negative, negative 1 parenthesis a minus 4, I have two negatives, and that makes a positive. So all I need to do is multiply both top and bottom by a plus 3, a plus 3. So I come up with 2 times a minus 4 plus 3 times a plus 3 equals 2a minus 2, and this side is over a squared minus a minus 12. This whole side is all over a minus 4, a plus 3, which is the same thing as a squared minus a minus 12. And so here's the deal. If I have two fractions, and I have the same denominators in the two fractions, and the two fractions are equal. If the denominators are the same, the numerators must be the same. X must, in this case, equal 17. In the same way, if the denominators of two fractions are the same, then the numerators of the two fractions must be the same. So I can ignore the denominator altogether for a moment and just say 2a minus 8 plus 3a plus 9 equals 2a minus 2. And ignore the denominators for a moment. That gives me 5a plus 1 equals 2a minus 2. 3a equals negative what? No, negative 3, because I'm minus 1. That's why we show our work. And so a equals negative 1. There we go. Now, at this point, we have to go back and look at the denominator. Because if we don't stop and go back and look at the denominator, does a minus 1 make this problem invalid? I could put a negative 1 there, that's okay. I could put a negative 1 there, that's okay. And I could put a negative 1 in for a here, that's okay. So, what is the answer? A equals negative 1. Let's take a look back over here. We came up with y equals 3 and 2. Is 3 okay here? Yep. Doesn't cause it to be undefined. Is 2 okay here? Yep. Doesn't cause it to be undefined. So, solving rational equations is something we've done in Algebra 1 and Algebra 2. Should not be a real challenge, but wanted to highlight a couple things for you. It's really just fraction rules. Again, fractions, fractions, fractions. So, with that, you have potentially a couple homework problems. Okay, ladies and gentlemen, we have some homework to do. That's going to be page 138, 33 to 39. Must write the problem, must show all the work, must give the answer, must verify that they are actual solutions that do not make it undefined.